And thanks for being here. So I have a research and extension appointment here in the department, and in the extension programs, I participate in the Institute for Art Professionals. There are many programs that we basically cover the whole state with the teaching components that we have. And then since I've been here, I developed and organized the Nitrogen Minnesota Grand Talents and Opportunity Conference. And as the title says, it is a conference dedicated completely to nitrogen and issues related to nitrogen and what I do. And then I have 4 students right now. Jason Clark is a PhD student, Gabriel Payao, Natalie Ricks, and Jared Stackman are 3 MS students, and both Jared and Gabriel are continuing to their PhDs after this fall when they graduate. And then I supervise or co-supervise with Dan Kaiser, Eric, Darby, Thor, and Nick. They are our field crew people. They help us with all the crazy projects that we have out in the field. They're a great resource. And then Karina Fabrizi is also a researcher that works with me. In terms of my research interests, I am really interested in the processes that impact crop production and the environment. And then in terms of teaching, my great interest is in mentoring students to help them think critically, look at patterns, and then be able to come to solutions using sound principles. In terms of my passion, soils is my passion. I love soils. I have loved soils since I was a little kid. And I really love discovering. I was the type of kid that will break the toys to see how it worked inside. I have always had that desire to learn and figure out how things work. And I also love teaching and mentoring. These are my students, Jason, Gabriel, Natalie, and Jared. And that's one part of my job that I love, is being with them. And then the other part is sustainable agriculture. And what I mean by sustainable agriculture is trying to produce as much as we can with the least possible environmental impact. And my goals basically reflect that. Now, I have a presentation later that is 3 minutes, and so I figure I'll practice with you guys. So I'll talk about some of the research that I do, and I want to highlight some of the main things that I focus on. I like to take more of a really approach looking at the research in different angles to try to understand the system. And so these particular 3 slides are just one project, and this is part of what we are looking at in this project. Mineralization is a huge component. Nitrogen mineralization is a huge component of what I am interested in looking at. And so in this particular study, we have unfertilized and fertilized conditions under drain and undrained conditions. So the undrained is the orange, the drain is the blue. And we have done incubations both in the lab and in the field. And one of the things that is very apparent here is that what works in the lab doesn't necessarily translate to the field conditions. This is when we apply no nitrogen, we predict that there will be a lot more nitrogen mineralized than we actually measure in the field through the whole growing season. And then in here, when we apply nitrogen, we actually saw that drainage had an effect, and then we saw the opposite happening in the field. That was 1 year, and the next year it was the opposite. So there are a lot of challenges and a lot of things that we don't understand yet that we need to understand. So I'm focusing a lot of my research on that. The other part is in terms of nitrogen losses, and so this is looking at nitrogen losses in the environment to the atmosphere. So looking at nitrous oxide emissions, again looking at this drainage system, drain and undrain with different nitrogen management, and looking at nitrogen in terms of total emissions and then emissions per unit of grain produced. And we see that drainage has a huge impact in terms of nitrous oxide. We also see that nitrogen has an important impact, and the single pre-plant application may not be the best way. The split application, applying the same amount of nitrogen, may have more benefit. And then finally, looking at nitrate loss. So this is more for the water quality aspect. We look at it directly, looking at nitrate leaching, but we also look at it indirectly, and that's what we are doing in here. This is totally inorganic N at the end of the growing season, and we see here that improving nitrogen production, so when we get the optimum, if we get to that point and we know where that is and we manage nitrogen that way, we can also improve the environment. We look at the residual nitrogen. There's very little what is left at the end of the growing season if we get to that point, but you see this exponential increase at the end of the season if we over-apply. Thank you.